Reverse proxy, load balancer, API gateway. Three things that sit between your users and your code. Everyone confuses them because half the time, they're the same tool wearing a different hat. But here's the thing nobody tells you. In production, you're probably running all three, stacked on top of each other. And when your rate limiter isn't firing and you can't figure out why, it's because the request never even hit the gateway. It got stuck 2 layers back. So let's follow a single HTTP request from a browser to a backend, through every layer, and watch what each one actually does to it. When your request hits a service like Cloudflare or Nginx, you're not talking to the actual server. You're talking to a middleman that pretends to be the server. That's a reverse proxy. Quick distinction. A forward proxy hides the client. Think VPNs and corporate firewalls. A reverse proxy hides the server. Your users never see the real IP of your backend. Attackers can't target what they can't find. But hiding IPs is just the start. The reverse proxy terminates your SSL connection, so your backend doesn't burn CPU on handshakes. It caches your static files so the same image doesn't get served 1,000 times from your app, and it compresses responses before they leave. If you've ever configured Nginx, you've set up a reverse proxy. Open any nginx.conf and it looks something like this. That proxy pass line, that's the entire reverse proxy, one directive. It takes incoming traffic and forwards it to your app on port 3000. The static block serves files straight from disk. Your app never sees those requests. If you want to actually type this config yourself and watch it work, Linux Dojo has a lab for that. Link in the description. Useful even with a single server. But what happens when one server isn't enough? Your app blew up on Hacker News. One Nginx box can't handle it, so you spin up 3 copies. Now you have a new problem. Who decides which server gets which request? That's a load balancer. It distributes incoming traffic across a pool of healthy servers. 2 goals: handle more traffic and don't go down when one server dies. Most load balancers default to round robin. Each server takes turns. Simple. Works. But when one of your endpoints streams video and another returns JSON, some servers are sweating while others are idle. So you switch to least connections. Whoever's least busy gets the next request, and then someone opens a support ticket. My shopping cart keeps emptying. Because their requests are bouncing between servers and none of them share session state, you could pin clients to servers with IP hash. Or you could just go stateless. Use JWTs, store sessions in Redis. Don't make your load balancer compensate for your architecture. Here's a distinction that actually matters in practice. Layer 4 versus Layer 7. A Layer 4 load balancer works at TCP. It sees IP addresses and ports. That's it. Fast, but blind to what's actually in the request. Layer 7 understands HTTP. It reads URL paths, headers, cookies, route.ap users to one pool, your API orders to another. Smart routing based on actual content. AWS gives you both. ALB for Layer 7, NLB for Layer 4. Nginx and HAProxy handle both. So a load balancer is really just a specialized reverse proxy with one job: distribute traffic. But neither of them handle auth, or rate limiting, or API versioning. For that, you need a different animal. In a microservices world, you might have 30 services. Without a gateway, every single one needs its own auth logic, its own rate limiting, its own logging. That's 30 places to screw up the same thing. An API gateway centralizes all that at the edge. Your request hits the gateway first, and it decides if you're even allowed in before your services see a single byte. Authentication. The gateway validates your JWT or API key. Bad token? Rejected. Your services never waste a CPU cycle. Rate limiting. A client hammering your API. Maybe a bug. Maybe abuse. The gateway cuts them off. 100 requests per minute for free tier. Exceed it and you're done for the day. Request transformation. Your mobile app sends JSON, but your legacy backend expects XML. The gateway converts it in transit. Backend doesn't change. API versioning. You ship V2, but half your clients still run V1. The gateway routes V1 users to the old service, V2 users to the new one. Smooth migration. Kong, AWS API Gateway, Tyke, they all do this. And here's the thing I really want you to sit with for a second. Kong, the most popular open source API gateway on the planet, is literally built on top of Nginx. Same Nginx from the reverse proxy section. Same config language. Same core. That means your reverse proxy, your load balancer, and your API gateway. They're the same tool at different zoom levels. Every feature we've talked about is just another layer of behavior on top of receive request, forward request. And that's why everyone confuses them. These aren't three boxes on a shelf. They're a spectrum. On the left, forward requests, terminate SSL, cache responses, core reverse proxy. In the middle, add traffic distribution, health checks, failover, load balancer territory. On the right, bolt on auth, rate limiting, transformation, analytics, API gateway. Nginx starts on the left but stretches to the middle. Kong covers the whole thing. AWS sells them as three separate products with three separate bills. Because of course they do. The question isn't which category is this tool, it's which capabilities do I need? Here's what a real request looks like hitting a company like Stripe. Browser fires a request. First stop, a CDN. Cloudflare, CloudFront, Fastly. That's a globally distributed reverse proxy caching static content at the edge and absorbing traffic spikes. API requests pass through to the API gateway. It checks the auth token, enforces rate limits, routes to the right service. Behind the gateway, an ALB distributes traffic across instances of that service. One goes unhealthy. It's pulled from the pool automatically. At the service level, another Nginx handles internal SSL and serves local static files. The request finally hits your application code. Response goes back the same way. Whole trip, maybe 200 milliseconds. 4 layers deep, each one doing something different. None of them redundant. But here's what none of the other tutorials tell you. You don't need 4 layers on day 1. Side project? Nginx as a reverse proxy. 20 lines of config. $0 a month. Startup getting real traffic? Add a load balancer behind it. 2 or 3 app servers. Now you have uptime. Public API with external developers? Now you need a gateway. Auth, rate limiting, usage tiers. Can't do that with nginx.conf. Enterprise scale, 50 microservices, 10 million requests a day. Full stack, CDN, gateway, load balancer, service mesh. The biggest mistake is over-engineering on day 1, running Kong, 3 load balancers, and a service mesh for an app that gets 50 requests a day. Your AWS bill will be the only thing that scales. Reverse proxy, forwards requests, terminates SSL, caches content, general purpose, load balancer, distributes traffic for scale and uptime, specialized reverse proxy, API gateway, manages APIs with auth, rate limiting, versioning, API-focused reverse proxy. They're not competing, they're layers. Match your architecture to your traffic, not your ambition. Remember that nginx.conf from earlier. Linux Dojo has hands-on labs where you configure all 3 of these from scratch. Reverse proxy, load balancer, and gateway. No slides, just a terminal. Links in the description.